Hey everybody, this is Larry. This is day 14 of the January Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. So my disclaimer is that I usually read, explain, and solve these problems live. So if it goes a little slow, just fast forward through it. Let me know what you think. It's a different format. Okay, minimum operations to reduce x to 0. You're given integer nums. You could remove left or rightmost element and then subtract this value from x. Notice this modifies the array. Okay. Okay. So this is a tricky one. I think, to be honest, my initial reaction is to do dynamic programming because it's easy-ish to do. But then, and that's why I scroll down a little bit to see what the n is, and n is 10 to the 5th, meaning that dynamic programming is probably going to be too slow. And then my second thought after that, after I saw the n, I'm like, okay, is there a greedy algorithm, right? And then I'm thinking about it some more. The reason why I thought about dynamic programming is because, in a way, it's brute force, so I don't have to think about in a way, I don't have to think about how to prove it. But for greedy or something like greedy, it's actually not that bad. My immediate thought after that was just, okay, actually, this is just either the prefix or the suffix. We can do some sliding window stuff. We can, I think, yeah, one way to do it is just sliding windows. The other way to do it is, by just like, okay, what's the biggest prefix? What's the suffix? The key thing to note is that all the numbers will have to be positive. If they're negative numbers, then that may not work out so well. So then my other idea, which I think should work after that is, and I think this is because I've seen either this problem or something similar, and I've kind of messed up a few times the last couple of times that I've done similar problems. And this is just like I wouldn't say a trick or a technique, but it's something that I'm reminded of. And this comes up with other similar problems as well that are not greedy, which is that, okay, given an array, given this array, instead of looking for 5, we can find because we're only removing from the beginning or the end, we can also actually find the inverse, the reverse of the inverse. Basically the opposite of this problem, where instead of finding what's at the end and something to 5, we could find it at the middle, such that everything minus the middle is equal to 5, if that makes sense. And I think once with that idea, you can do the math. And the math, I think, is just you sum up all the numbers, and then you want to make it so that now your new target is whatever your new target is, the total minus x, which is in this case 5, and then you could use a prefix sum dynamic programming, or which is actually, I mean, I guess it's still dynamic programming, but I consider it greedy in how I think about it. And yeah, and prefix sum dynamic programming is one of those weird things that I always say is, you just have to get experience in practice. And to be honest, it's one of those things that historically I've been bad about it, but because Leetcode has quite a few of those problems, I have gotten better about it over time. The reason is, and I've mentioned this on my stream sometimes, which is that when I started competitive programming, people didn't use the libraries as much because they were slow, like STL was slow, and it's just not standard across different languages. Like Java wasn't even supported in ICPC back then. I could be wrong about that one, but even if it did, like, you couldn't use certain libraries depending on the rules of the competition. So anyway, my point there is that there was no set, there's no dictionary really. I mean, maybe a little bit, like, at least if they exist, you have to implement it, which is so they didn't ask these type of problems. Anyway, that's a little bit too much background maybe, but yeah, let's kind of go into it. So what we'll begin with is just having, like we said, so total is equal to the sum of the nums, and then let's just call it target is equal to the total minus x, right? And then now we're going to do some prefix sum. I think I have a video on it, so maybe I'll link it below. But prefix sum is one of those tricky things that you just have to practice a bit to kind of get the nuance about. And yeah, I mean, usually I skip the prereqs, but I'll go over it very briefly. So basically what I have is, okay, so I have prefix sum is equal to, let's just say 0 times n plus 1, n equals number of nums. And I get a lot of questions on like, why is it n plus 1 and off by ones and stuff like that, prefix sum. The way that I think about it is that, and like, I like to visualize, is that sometimes people think about the indexes of the prefix as the numbers themselves, and I think that's some parts of it is coincidence. And you have off by quote unquote off by 1 or shift by 1 or whatever. But the better way that I think about it is that instead of the indexes being the numbers, actually I prefer to think about it as the indices as these commas or spaces that are between the numbers, right? So then now this one is index 0, this is index 1, and so forth, right? Dot dot dot. I mean, I think you can draw the dots. And then now it becomes more clear what the prefix sum array represents, because now the prefix of 0 is just the sum of the first number up to the first space, which is 0 numbers. So the sum is just 0. And likewise, the sum of the first one number, it's going to be just the first 2 spaces and the sum of the numbers in between. And also likewise, just to give a number, so the sum of the first 4 numbers will be the 5th space, which is 1 2 3 4 5, and then it's just the sum of these 4 numbers, right? So basically that's how the indexing works. I think sometimes if you get off by 1, it's a good reminder to think about why, because I think sometimes people speed it up and they don't really understand why the indexing is like that. So I just want to go over it really quickly, even though yeah, and the sum part is just you just calculate the sum in the to that index and put it in an array. So I know that maybe this is not an in-depth explanation of prefix sum, but this is a video about this problem and not just prefix sum. So that's where I'm gonna stop now. Let me know if you have any questions about that, and maybe I could do something on the other video. But yeah, so now we have for say index in range sub n. So then now we just have prefix, and this is standard-ish, is equal to prefix of index plus num sub index. This is just saying that for each prefix element, you just sum it from the previous one. So this becomes a rolling sum of sorts. And then now from that, now we just have to keep track of, in this case, is it the longest or the shortest? Minimum operations. So another way of phrasing this is that the minimum operations to remove from the ends mean the longest in the middle, right? Because then the longest in the middle, then you have shortest to remove from the end. So then from that, yeah, we can do, okay, longest in the middle. And what does longest mean, right? Well, we'll explore that in a second. But first, we have to see have a sort of a scene array, or last scene, right? And now for index x in enumerate nums, how do we go by it? Oh, and we also want to add the prefix of 0. And we want to set it to -1. In this case, I mean, there are other ways to do it. You can have additional if statements if that makes more sense. But what it comes out to is that you could kind of treat the last, because if you treat the index of the last of the first number as x, then as the index, then the number before the first number would be -1. You could also add 1 to the other direction. I think either way is, as long as you're consistent about it, it should be fine. Okay, so then now we go, okay, if, we might need a little bit more variables, but actually we don't even need x. Do we even need this array? No, I don't think so. We just need a prefix array. So okay, let's do this then. And then we go with prefix of index Actually, yeah, maybe I'll do it the other way. So just ignore what I said about the zero first. So if prefix of index is in last seen, well, what does this mean, right? Well, this means that we've seen the prefix sum. Oh no, this is not right. Oops. Okay, so then now we have target, right? So basically the prefix sum is such that prefix of index minus some other previous number is equal to our new target, right? Basically, that's the formula that we want to do. And then now we just have to move the formulas around so that we can search our last seen array. So then we minus target on both sides and then add previous on both sides. So this is the number that we're trying to see if it exists. So yeah, previous seen maybe is equal to previous, prefix index minus target. And then we check now if this number with previous seen is in last seen. That means that we've seen it before. That means that the prefix sum exists. Then we have I guess a best array. So we want to, in this case, we want to keep the longest. So for now, we'll just have 0 where we remove everything. If it's impossible, then we return -1. So it is possible that it is not possible. So let's have yeah, let's have a -1, I suppose, so that we know that if it's negative, then it's not possible. So if this is true, then the length of this the length of the segment that we overlap will be prefix of index minus prefix of previous seen. Maybe off by 1 there, but yeah. But then now we just get the max of this. I'm trying to think whether if target is 0, we have to do anything funky. So maybe we still need to think about, or like target is the entire sum, then you have to remove 0 elements, and we might still have to, no, I mean, because okay, I think we're good because the first index will make it 0 anyway. Okay, and then at the very end we track prefix of index. We put that into the last seen array, and also I think I messed up here. I meant it should be last seen of the previous scene, because that's the number target, and that's the that represents the index that we put in, right? So this is index here is equal to index. Okay, and then now we just have to if best is less than 0, we return -1, even though I know that's -1, but otherwise we return the length of nums minus best, because this is the length of the longest sequence, and then this is just the rest of the array, right? So then now we can give it a go, see if I have any bugs or typos or whatever. Let me also copy and paste. No, there's -2. No, that's not good. Run it again just to see if it's Huh. Well, that's a little bit odd. Did I mess up the signs? I think this should be right, but I did it a little bit quick. Okay, well, let's take a look at some variables. Actually, usually I have a good idea of where the error is, but I don't, unless I misread the problem. But either way, I shouldn't have -17, so that's probably not it. Let's take a look at the prefix array just to see that it's correct. This looks good. So we do want 11 minus 6. So in theory, unless I'm off by 1 here, let's see. Okay, so this is looking for -6. Huh, this seems like there's an off by... This is off by 1, right? Because we should look for negative... Huh. Maybe I have an off by 1 somewhere, hang on. That's the beauty of doing these live. You have all these beautiful theory, but then you still make a silly mistake somewhere. Yeah, why is previous seen -6? Did I mess up something? This prefix of index is there should be 0. 0 minus x. Oh, wait. Oh no, okay. So that's, the sum is 11, so it should be -6. Okay, that's actually right. But index previous seen is 5. 5, does it exist? Maybe I did I do this wrong? Oh, I did do this wrong. I think, okay, I just misread the problem, that's all. Wait, did I? No. You want, no, this is, right. We want the inside to be 6, which in this case is either this or this. Yeah, okay. So this is previous seen as 0. So okay, so we move. So this should give us, because 0 is definitely previously seen. So this should give us some answer. And here as well. So that means that I just probably have some weirdness somewhere, which is with previous seen isn't last seen. It should be, unless I didn't set it correctly. That's odd. Okay. Do I want the max? Yeah, I do want the max. Okay, that's previous prefix. Oh, I am just, okay. I am dumb. Okay, so we want the difference between the two index, and not the number. I don't know why I did this way. But yeah, basically this is the index of the last time we saw it, and this is the current index, right? So yeah, okay, that was just silly. Okay, so that looks way better. Apologies for that. Let's give it a quick submit. Hopefully there aren't any weird edge cases, in which I guess there are. Huh. Why is this -1? Dong dong dong. I don't have any overflow or anything like that, so let's kind of see. So this never happened. What is this number? Why is it 16? 1, 2, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, it's the entire way. This is the case where it is the entire way. I thought do I not keep track of 0? Huh. I thought I definitely should have tested this case, but so because I was talking about it even, but I thought I did handle it. Let's have a simpler one. That should be like 5 by 5, 15. If we're right, this should be wrong consistently. Or we're right about why we're wrong. Yeah, okay. But I thought we put in the index 0. Dong dong dong. Oh, I actually thought about this while I was doing it, but I wasn't. Also, I have another bug which I'm wrong anyway. So yeah, I forgot a few things with respect to how greedy we want to do. One is, and I thought about this case while I was solving it, but I think I mixed up getting the max and the smallest, and I kind of reworded them. So the two things, right? One, okay, that's my fault. we have to figure out how to maximize it. And the thing to maximize is that in order to maximize it, we want, for this line, we want to, and this is actually not related to this bug, but to maximize, we want to see the earliest index to get this. So then now we have to add this to be if prefix of index is not in last seen. And the reason why we need this is if we want index to be the smallest number as possible, to be as early as possible, so that we maximize the length. So we've seen it before, we would override it. And then the other one is just that we can move it forward. That's pretty much it. Basically, you could have a 0 length, whatever, and yeah. Okay, as long as that 0 length adds up to be 0. So let's try again. Just a little silly, a little bit rushed, to be honest. I just woke up, so yeah. Ooh, that was 2 silly mistakes, to be honest. Yeah, okay, so yeah, now this is accepted. This is tricky as I go with, and even with practice and on live, I make silly mistakes. So whoopsie daisies. But yeah, so what is the complexity of this? Well, we have a for loop. So yeah, this is going to be linear time for reasons that I hope you can see. We have a for loop, and for each loop we do a couple of hash lookups. So this is going to be linear time. In terms of space, we have a hash table and a prefix sum table, so that's also going to be linear space. Yeah, linear time, linear space. Let me know what you think. I think that's all I have for this problem. It's a little bit long, but I hope I explained in detail. I will see you later, and bye-bye.